we are going to see very important concept at the end of the infinite series, that is okay, this will be the last borderline for me. I am discussing now alternating series. Earlier we discussed completely about series of positive terms. Every test you see, limit comparison test, ratio, root and rabbis. Every test we have discussed with saying that sigma un is a series of positive terms. Now we are discussing alternating series. That all previous tests are discussed in part 1, 2 and 3. It is going to be the part 4. So if you have not seen, really I suggest you go to that parts, you will get complete clarity of all that infinite series right from the beginning. Some students are absent in the earlier classes. So make it a point that you really watch that all the 3 parts. Back to the point, alternating series. An infinite series whose terms are alternately positive comma negative is called, means an infinite series with this condition is called alternating. Don't be confused with that spelling and this spelling. It is alternatively, okay, alternatively positive and negative. This is alternating series. What is an example of that one? Example, so simple. Alternately positive negative means if it starts with positive, second term should be negative, third term should be positive, fourth term should be negative. 2 negatives, 3 positives, that's not allowed. We are not studying that type of infinite series. We are studying only those infinite series where we have alternately positive and negative. It may start with negative term, then it should be positive, then negative, then positive, like that. Example, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, so on. It may start with negative also, that I no need to discuss that one. What is the compact notation for this one? How do we write it in a simple form? That is, this can be written as sigma. Because of this summation, I am just writing sigma for that. How the terms are generated, you see, 1 by 2. This can be treated as 1 by 1. So 1 by 2, 1 by 3, 1 by 4. It is 4th term, 1 by 4. 5th term, 1 by 5. So it is nth term with 1 by n. So when n is 5, it will become 1 by 5. Is it clear? Okay. So it's not looking good. So I just write it 1 by n. Now something should be there to generate, to create this positive negative alternately. That is done by minus 1 whole to the power of n minus 1. When I substitute n value 1, what comes? 1 minus 1, 0. Minus 1 to the power of 0, that becomes 1. Next time when n is 2, 2 minus 1, 1. Minus 1 power 1, that is minus 1. That is this minus. Alternately plus and minus will be generated with this minus 1 to the power of n minus 1. And n runs from 1 to infinity. If you want the first term to be negative, you have to use minus 1 power n. So that n value 1, it will become minus. So every alternating series can be written in this form, or sigma minus 1 power n into un. So this is example for this one. In general, how it will be? In general, alternating series will be what will be the form? Will be sigma n is equal to 1 to infinity Very good. Minus 1 whole power n minus 1. If we want to start with the first positive term, that is minus 1 to the power of n minus 1. What will be there afterwards? It may be 1 by n, it may be n by n plus 1, whatever it is. So it will be some un. So this will be some un. Or what is another form for this one? Very good. Sigma. In general, alternating series will be this or this. N is equal to 1 to infinity minus 1 to the power of n un. But be careful, un should be always positive. This is 1 by n. This is always positive. If it is always positive, this un, if it is always positive, then alternate plus minus will be generated by this one. Suppose if one of the un is positive, some un is negative, then negative and this minus will become plus. So alternate sign will not be generated. So what is the requirement? For this un, for every n, for all natural numbers, un must be positive. So what should I write it here? In general, alternating series will be this form or this form where un is greater than 0, that is positive for all n. What is this n? Natural numbers. No need to tell that because un will be a sequence and hence the domain must be set of natural numbers. Already we have done it in the beginning, first class. So this is the case. At least now shall I feel that you are all clear about alternating series? Either that form or this form. Clear. Now one very important point to be noted here, that is, in alternating series or whatever series you take, if you remove some terms, finite number of terms. Actually infinite series will be having infinite number of terms. From infinite number of terms, if you remove finite number of terms, 10 crore terms or 100 terms or 20,000 terms, how many you are removing? Finite number of terms. Finite number, not infinite number of terms. You are removing finite number of terms. Nature, then nature does not change. Means if it is convergent, after removal also it will be convergent. If it is originally divergent, after removing also divergent. Nature will not change. By removal of removal. How many removal? Finite number of terms. The nature does not change. Similarly, if you add finite number of terms, nature does not change. If it is convergent originally, after adding also it will be convergent. If you remove some if you add some terms and originally it is divergent, then also it will be divergent. So, what is the conclusion to be kept in mind? The nature of series, not only alternate, whatever it is, the nature of a series does not change upon removal or inclusion of finite number of terms. Be careful, finite number of terms. This is one point to be noted. Second important point to be noted is that if we multiply a constant to the infinite series, that constant is not equal to 0. Let it be negative constant or positive constant. Then the nature does not change. Nature does not change. Why I am saying nature does not change? So simple point, that is, for example, take sigma 1 by n square. How it is? It's a p series. It is a p series. What is the p value? 2. It is looking like sigma 1 by n power p. P value is 2. That p is equal to 2 is greater than 1. Therefore it is convergent. It is convergent. When it is convergent, it will have a finite value as the summation of the series. Is this point clear? Whenever you say a series is convergent, the meaning is that the sum of all the infinite number of terms is unique finite quantity. Now, sigma 1 by n square is a unique finite quantity. If I multiply 10 to this, what happens? Whatever total is here, that will become 10 times now. 10 is multiplied to every term, suppose, every term. 10 is common. So, how much total is there here? That into 10 will be again finite unique quantity. Therefore, if it is convergent, Actually, this is convergent. Therefore, multiplying with 10, that is also convergent. If you take sigma 1 by n, this is divergent. Divergent, p value 1. Divergent. So when it is divergent, meaning is that you go on adding the terms, the total goes on increasing. There is no limit to that. Therefore, we cannot find the sum of all the infinite number of terms for this one. So the total will be infinity if you add up all. When it is infinity, 10 times if you multiply, then that is also infinity. Therefore, nature does not change if you multiply with a constant. If you multiply with a positive number, whatever total is there, the total will get 10 times multiplied. If it is minus 10, the total will become minus 10 times. So the nature does not change. But what happens if you multiply with 0? Complete series will become 0. 0. Complete series with 0. Total is 0 only. Therefore it is convergent. So sigma 1 by n is divergent, but you multiply with 0, that will become 0. So the actual series is lost. Whether it is 1 by n or 1 by n square, multiplying with 0, it will completely destroy the series. So you cannot say anything. Finally, what is the conclusion? You can multiply a constant, but non-zero constant. Then the nature does not change. Now tell me, what is the difference between that series and this series? Minus difference will come. It will start with u1 minus u2 plus u3 minus u4, so on. It will start with minus u1. Minus u1 plus u2 minus u3. If you take minus common, then this series total will be this one. Therefore, if it is convergent, this will be convergent. If it is divergent, this will be divergent. So, this is just having difference of minus. Therefore, nature does not change. So, how it is? Like this it is. Are you clear to here? So, if a test is applied and you check that this is convergent, you can simply declare that is also convergent. So now comes very special test called as Leibniz test, to be applied only for alternating series. Okay, you take the photo for this one. You didn't take, no? You take the photo for this one. Or now, how many of you are really listening with concentration will be very clear? What is the name of the test just now I discussed? Good, very nice. Leibniz test. Each and every word is important in mathematics. Whatever we write, every word plays important role. Now, what is the test I am saying? Once this test is over, I expect you to repeat along with me what is this test, if I ask you. Otherwise, no need. So, if un, I am not writing sigma, carefully see. I am just writing sequence. Bracket un is a sequence, is a decreasing sequence. How it is? Decreasing sequence of positive terms. Positive terms. How should it be? u1 should be positive, u2 should be positive, so on. u1 value, whatever comes, it should be greater than compared to u2. Means u2 should be smaller than, every coming term should be smaller than the previous one. So it should go down. Example of decreasing sequence, 1 by n, 1 by n, un is equal to 1 by n. So what will be u1? 1. What will be u2? 1 by 2, 1 by 3, so on. It is 1. It is 0.5, 0.33, 0.25. It goes down, right? So it is an example of a decreasing sequence of positive terms. No negative term should be generated in this un. And limit of this un as n tends to infinity should be equal to 0. Then this Leibniz test says some conclusion. What are the requirements to apply Leibniz test? It should be a decreasing sequence and its limit should be 0, equal to 0. Then sigma minus 1 power n minus 1, n is equal to 1 to infinity. Means whatever un you have calculated the limit, that un you attach with minus 1 power n minus 1 to adjust minus plus alternately, then that summation is convergent. This is the statement of Leibniz test. I hope you are all clear about this. Let us see a problem where we apply Leibniz test and declare that how it is convergent. One thing very important, if it is decreasing sequence and the limit is 0, then only this is applicable. Suppose if the limit comes not equal to 0, no conclusion you have to draw. You should not apply Leibniz test. Leibniz test is not applicable when limit becomes not equal to, when it is 0 and it is a decreasing sequence of positive terms, only then we can declare that the alternating series is convergent. Okay? Chalo, let us do a problem. So simple you see. Test the convergence. Test the convergence of the series. That series is sigma minus 1 to the power of n minus n into 1 by n. N is equal to 1 to infinity. Solution. Very important point to be noted here is, this is un. What is un here? 1 by n. Including this minus 1 power n minus n, we sometimes call it as an. An will be now minus 1 power n minus 1 into un. Means this much part, where it is, okay, this part. This complete we will be denoting by an. From here onwards, whenever I write an, I mean this complete. Un is only this much. With this completely, it is an. Sometimes I denote like that. So n is equal to 1 to infinity. Here, what is un? 1 by n. Un is equal to 1 by n. What will be the terms, you tell me? Un will be 1, 1 by 2, 1 by 3, so on. It is a decreasing sequence. You can also prove how it is decreasing. But I am avoiding that proof. I am directly saying that clearly I am writing clearly un is a decreasing sequence of if you can catch it, you catch it, otherwise you leave it. I'll try to prove in short, fast, how it is a decreasing sequence mathematically. U2 should be greater than U3, am I right? U101 should be greater than 102, like that. Means UN should be greater than UN plus 1. To prove this, I will take minus here, means I'll take this here. I should prove that it is greater than 0, right? I should prove UN minus UN plus 1 is greater than 0. Then this goes that side, UN will become UN plus, greater than UN plus 1, therefore it is a decreasing sequence. So what is that I have to prove? UN minus UN plus 1 greater than 0. So what is the value of UN? 1 by n. What is the value of 1 by UN plus 1? 1 by, okay, come on, n into n plus 1, n plus 1. So this gets cancelled. 1 by n into, what is n? Natural number. So n plus 1 is again a natural number. Positive. 1 by positive is positive. So this is greater than 0 for every n value. Therefore un is greater than un plus 1. I am not doing that work because sometimes the calculation will be lengthy depending upon un value. So you can avoid in the examination if you have less time. Otherwise you do this full work if you have time. Otherwise you skip it. So clearly un is a decreasing sequence of positive terms. Now what is the limit? That is, you have to check these two conditions. No, first thing is over, finished. Now we are checking limit. So now limit n tends to infinity. Un is equal to limit n tends to infinity 1 by n. What is the meaning of this? When n becomes bigger and bigger, moving towards infinity, what happens to 1 by n? 1 by n becomes smaller, closer to 0. So 0 is the limit. So finally, in short, it is 0. Limit un is equal to 0, you got it? Therefore, by Leibniz test, sigma minus 1 power n minus n into un is convergent, right? I am writing in the same fashion. What is that? This one. But now I will replace it. Un value with 1 by n. So what I get it now? Therefore, sigma minus 1 power n minus 1. You can skip n is equal to 1 to infinity. It is understood always. So this into 1 by n is convergent. I hope you are clear, right? Did you take the photo of Leibniz test? No, you take it fast, quick. Okay. Right? Now comes very interesting issue, that is, how is sigma minus 1 power n minus 1 1 by n? Just now we have proved it, no? Convergent. Convergent we have proved or not? By taking the help of Leibniz test. If I call this as sigma an, means this series I am calling as sigma an, then an means this complete. This is completely our an, this an. Okay? So sigma an is convergent. Now I will apply mod to this an. I will see how is sigma mod an. Sigma mod an means sigma mod to this one. What is happening here? Alternately plus minus, right? But when we apply mod, all terms will be positive. So no need of writing this one. When you apply mod, this will be gone. So it is just a sigma 1 by n. How it is, you tell me? What, Krishna? What is this? It is P series. What is P? 1. Divergent. Do you remember the conditions for P series? P1 or less. Divergent. Greater than 1, then only, just that side, greater than 1, then only convergent. 1 or less, divergent. It is 1 here, so it is divergent. Divergent. Now the interesting thing is, it is convergent, sigma an, sigma mod an is becoming. Now tell me, this is convergent, this complete is convergent because of the presence of this minus 1 power n minus 1, no? If you remove this, it's becoming this, you just remember, I am saying for understanding it in a better way, convergent means life, divergent means dead. Okay, like that you keep in mind. Now, this is life. This life is depending upon the presence of this. It is like a ventilator. It is like a ventilator, you know. If the person is in critical situation and needs ventilation, then, needs ventilator, he will be, or she will be, that patient will be kept. If the ventilator is removed, patient will be gone. So this is convergent under the condition that this is present. If this is removed, it is becoming divergent. So its convergence is depending on the presence of this ventilator, that is minus 1 power n minus 1, minus 1 power n minus 1. So this type of convergence we call it as conditional convergence. Conditional. Understood this one? Next is one more concept called as absolute convergence. Absolute convergence. It is such an infinite series, it will not depend on minus 1 power n minus 1. Whether it is kept or removed, in both these situations it will be convergent. That type of infinite series we call it as absolutely convergent. But the concept is absolute, or the property is absolute convergence. Can you think of an example of absolutely convergent infinite series? Very good. Sigma 1 by n square. Now, if you take up this, apply Leibniz test, you will get it as convergent, because limit is also 0 here in this case. Limit un is limit 1 by n square. Limit 1 by n square is also 0. It is a decreasing sequence. Therefore, by Leibniz test it is convergent. And if you apply mod to this, it will become sigma 1 by n square. This is also convergent, and hence it is absolutely convergent. But there is one very special point to be noted, that is, there is a theorem saying that if a sigma mod an is convergent, then sigma an is convergent. Meaning understood? Without this means taking sigma mod n. If it is convergent, then remove the mod, apply this minus 1 power n minus 1, it will be however convergent. Now tell me, if this is convergent, means this one better. If this is convergent, theorem saying that this is convergent, so no need to check this one. So what can you say? Directly, if sigma mod an is convergent, we can declare that it is absolutely convergent. Actually, both should be convergent. Sigma an should be convergent and sigma mod an should be convergent. That one theorem is helping us. What is that theorem saying? Sigma mod an is convergent, then no need to check about sigma an. That will be however convergent. So what is the conclusion now? If sigma mod an is convergent, then we call it as absolutely convergent. Now, can anybody just tell what is this is not required, we do the problem, instead of taking the photo for this one, just for sake of explanation I have written. Now, tell me what is the condition for this conditional convergence. I will write it now. Can you tell the definition for conditional convergence? Sigma an is convergent, first of all. Sigma an is, and sigma mod an is divergent. So I will write it conditional convergence. Actually, alternating series, we have convergence, suppose, then this convergence is divided into two categories. Convergence in the case of alternating series, this will not play any role in the series of positive terms. For alternating series only, we will categorize that it is absolutely convergent or conditionally convergent, right? So is this point clear? So let us write the definitions. What are the definitions for conditional convergence and absolute convergence? So let us make up the definition. Conditional convergence. If sigma an means I am including minus 1 power n minus 1 along with the un. So that is sigma an. If sigma an is convergent and Very good. Sigma mod an means that minus 1 power n minus 1, you are removing it. You are applying mod means you are removing that. Means you are removing the ventilator. So what comes now? If this is convergent and the ventilator removed, it is divergent. Then sigma an means this complete with minus 1 power n minus 1 un. That is conditionally. Then we say sigma an is conditionally convergent. Example of conditionally convergent infinite series, come on, tell me. Example, sigma minus 1 power n minus 1 into 1 by n. This is convergent by convergent by Leibniz test. It is convergent by Leibniz test. Understood this one? Again, just I repeat in 10 seconds. This is un. It is decreasing sequence of positive terms. Limit is 0. Therefore, this is convergent by Leibniz test. This is convergent, and sigma mod of this minus 1 power n minus 1 into 1 by n is sigma 1 by n. I applied the mod, it becomes sigma 1 by n. This is divergent by P test or P series test. It is divergent. So it is convergent. After applying mod, it is becoming divergent. So sigma an is convergent and sigma mod an is divergent. Therefore, this is an example of conditionally convergent series. Therefore, sigma minus 1 power n minus 1 into 1 by n is conditionally. Be careful here. Don't write just sigma 1 by n. Sigma 1 by n is divergent. You cannot say sigma 1 by n is conditionally convergent. You have to write this minus 1 power n minus 1. With this, it is becoming convergent, and that category is conditionally convergent infinite series. Shall I assume everything is clear up to here? Just we will take up one more concept, that is absolute convergence. We will write the definition, we will take up a simple example, and this matter ends here. Then I would like to tell some more things in the next part, right? So first of all, let us finish. Oh, you are not written, no? Conditionally convergent series. So is convergent. Okay, take it. Better, just wait. I'll underline that. That's good. Take another photo. Or finished. Next, what shall I write? Absolutely convergent series. What is the condition, you tell me? No need to tell an is convergent and this is also convergent. No need. What? Very good, is convergent. No, not that. So simple. If sigma mod an is convergent, then we say sigma an means without mod, whatever an is there. When I write an, I mean minus n power n minus 1 is there available. Sigma an is absolute. Then we say this is absolutely convergent. Acha, just now I said one thing. Because of that help from the theorem, what is the best working style if alternating series is given? First you apply mod. If sigma mod an becomes convergent, then directly declare it is absolutely convergent and stop. The matter ends. So what is that you have to do? First apply mod. means remove the ventilator, check it. If it is coming convergent, declare that it is absolutely correct. Suppose mod AN is coming divergent, then you have to check sigma AN how it is. If it is convergent and mod is divergent, then conditionally convergent. Is this clear or not? Simply speaking, first you check sigma mod AN. There are two chances. If it comes convergent, declare absolutely convergent. If it comes divergent, then you have to apply Leibniz test. After applying Leibniz test, you have to show that it is convergent. Then divergent with mod, without mod convergent. Then you will declare conditionally convergent. So what is the working style? What is the flow chart? You know flow chart in computer science. You write that. Okay, you take the variable, you calculate that, then you go here, there, all these things. So what is the flow chart for us? What is the flow chart for us? First you calculate sigma mod n. Comes convergent, directly declare absolutely convergent. If it comes divergent, then apply Leibniz test. Without the mod, you calculate and check it. Declare that it is convergent and finally declare conditionally convergent. So what is an example for this one? Just now we discussed. Example. Sigma minus 1 power n minus 1 into 1 by n square. This is sigma an, right? I call it as sigma an. Therefore, what is sigma mod an? Sigma 1 by n square. Shall I remove directly this one and write sigma 1 by n square? Yes. And just to remove this, because I have applied mod. So remaining is only 1 by n square is convergent. Why it is convergent? P is equal to 2 greater than 1. I should write fully. P series, P value 2 greater than 1. Therefore, what is absolutely convergent? This or this, you tell me. This or this? First one, this one. So, sigma minus 1 power n minus 1 into 1 by n square is absolutely okay. This is the end of part 4. Some more important pending things, some important special things I'll discuss in part 5, and then we will start problem solving session. We will take up a problem, we will decide which test to be applied, because that is what is important. In the examination they will never give name of the test. We have to decide. So we will do the practice with taking a problem and then deciding what test should be applied. So by this, what are the things I discussed in these parts? All 4 parts you tell me. First I discussed GP, geometric series, better GS, geometric series, P series, limit comparison test, ratio test, root test, Rabbis test, shortcut for divergence, alternating series, conditional convergence and absolute convergence. These many things I discussed. So some pending things we will discuss in next part. Okay? Chalo, right, fine. Take the photo of this one.